Okay, so now we've assembled our PCB. Now the next step is to set up, to connect our mini hot plate so that we can run the reflow profile that we programmed in the first video on it. So you'll notice that here's the mini hot plate by Miniware, I believe, China-based company. And this is the MHP50. So MHP obviously short for mini hot plate, 50 corresponding to 50 by 50 millimeters, or 5 by 5 centimeters. And this one again is super affordable. For me, is like the perfect hot plate for prototyping. You can get it for $100 through Adafruit Industries. And if it runs out of stock there, then there's a $200 option through SparkFun. But if you can, get it through Adafruit. Now, the thing with this one is, as I probably mentioned in the first tutorial for programming and setting this one up, updating the firmware, is that it does come with a USB-C cable, that is USB-C to USB-C. And here's the slot in the back, right? So no need for this power slot. We can just connect this USB-C power to deliver, this USB-C cable to deliver power. And if we connect it to a laptop, well, it will be supplying 5 volts, which is enough, to update firmware and change up the configuration file. But 5 volts is certainly not enough. There's not enough power there to heat this thing up to hundreds of degrees. So for that, you do need a high power power supply jack. So this one from Amazon Basics, it'll run you somewhere between $40 and $60. And these things are a little heavy, but they're very nice because they're wall plugs or wall jacks, so you can plug it into an outlet. And this model in particular, the purchase details are included in the description to this video, but you'll notice that this comes with 12 watt USB-C ports, as well as an 18 watt USB-C, but this is what we want to use, right? So this one here maxes out at 100 watts. Okay, so the idea would be you plug this in to any wall socket or even a surge protector, and then the other end of this cable, you have to plug it in to this one. All right, so we want the 100 watt. The lower wattage is not going to work for our purposes. Okay, so I'm going to just pull over this power supply, and I'm going to connect it to a nearby power strip. Okay, so let me just show you what that looks like. So I've connected it here. When you do that, it's going to light up blue. So nice little visual cue to remind you that's where you want to connect the other end of that USB-C cable. So here it is. And we just connect it as so. And hopefully you heard that little beep beep. So now it's receiving power, and this is where we can take a look at the menu, right? So you can cycle through the menu, and I did showcase some of this in the first tutorial. So cycle forward is left, and or cycle down is this right button. So notice here's menu, and then info, reflow, and heat. So you can use the heat option to heat up this plate, and that's a nice little feature for preheating your PCB to make it easier to solder on surface mount components, where you might have some solid vias, right? Or if if it's kind of difficult, if there's a lot of copper, right, that's dissipating the heat, then that would make it difficult to solder. But if you preheat the entire PCB, it makes it easier, right? So there's multiple uses for this, but reflow is what we want, right? And as a reminder, if I press and hold this left button, I can activate essentially the option that's being displayed on the screen. So here, if I go into menu, press and hold. Now I can go down by, pressing this button on the right, and I just want to confirm that the reflow profile is what I want, right? So there it is, reflow. To go into this submenu, I press and hold the left button. There it is, and so here we can directly inspect the rise time, the rise temperature, the rise time, the keep temperature and keep time. So stages 1, 2, and 3, and the third stage is the welding, right? So weld temperature and weld time. So if I now click on the left button, I can go back up, and then if I want to view or change directly on here the rise temperature, I can do so by pressing and holding. Oops. Yeah, that's the other thing. If you don't press anything, after a few seconds, then it will go up a level in the menu system. So I have to press and hold menu, and then oh yeah, that's nice. So if you press this button in the menu, then it will take you all the way to the bottom. So press and hold, and I don't want to restore, I want to go to reflow. Press and hold, and then let's check the rise temperature. Yep, it's 90 degrees Celsius. Okay, and then see if I don't do anything, it'll escape, leave that. Now if I look at the rise time, 90 seconds, good. Let that read, okay. Keep temperature is 130 degrees Celsius. Keep time is 90 seconds. Weld temperature is 165 degrees Celsius. And notice the two arrows, so when we enter that, we can use these buttons to change those values directly on here. And then weld time is going to be 60 seconds, right? So it's about 4 minutes for this entire reflow profile to complete, but 4 minutes, again, as mentioned previously, is not enough. You want to, it's going to be very hot, like 165 degrees, right? So you want to wait like another 10 minutes or so until the temperature has gone down to ideally below 50 degrees Celsius on this plate. So now what I'm going to do is I'm going to just pause the video, and then when I unpause it, I'm going to bring in the assembled, quote-unquote, assembled PCB, place it on here, and we're going to start the reflow, and then I'm just going to do a time lapse to show, the whole thing in action. Okay. Okay, so unpausing, here it is, right? Now most, such a simple board like this, we would normally just hand solder because it's just one component. So, but for the purposes of this example, we're going to be using the hot plate. So you want to just carefully place it on the hot plate, and you notice how I could have placed multiple PCBs that I assemble, but here I just have the one, so I'm going to just set it in the center. And now I'm going to go to reflow, and then to activate the reflow, I'm just going to press and hold this. Okay, notice at the moment the thermistor, the sensor is reading 22, 23 degrees Celsius, and of course now it's going to start heating up the plate. And so you can see the temperature reading as well as the elapsed time. And what's kind of nifty is that it will also, it's also going to show here, the value, a little graphical view of the temperature profile over this time. And the idea is that it would match more or less what the card says, right, for this particular type of solder paste. Okay, so notice it's the temperature is increasing pretty quickly. And now what I'm going to do is stop talking and let this run, and you'll see a time lapse. Okay, so I'm going to try to zoom in a little bit more and see you in approximately, I don't know, 10 to 15 minutes. Okay, so notice now the temperature has finally reached the threshold of 50 degrees Celsius, and you can see the LED light is flashing green. Just a few moments prior it was yellow-green, but now it's cool enough that you can safely pick up the assembled PCB. Notice that it took approximately 14 minutes for this entire procedure, right? The actual reflow profile, that only took 4 minutes, but it took an additional 10 minutes for this plate to adiabatically cool down. And this is in an air-conditioned office, right? So, it might take a couple minutes more or less for this plate to cool down to a safe temperature. But now that it has completed, we can actually exit out of this by pressing and holding the right button. Okay, and then now we're back to the top level menu system. And what I like to do as well when I'm not using the hot plate is just disconnect it right there. So now if we just pick up the PCB, it's nice and warm, and let me try to zoom in a bit, but hopefully you can see that as opposed to before where we had this gray matte colored sludge, which was the solder paste, now that it's a bit shiny, right? So if you look at the side, right, then hopefully you can see that the metal contacts on the bottom are secured to the pads. And another little quick trick or thing to check is if you just gently rub it with your thumb, as long as it doesn't pop off, that means that it's secured on here. You could also use a digital multimeter, right? So because this is an inductor, you would expect there to, for current to pass, right, between the edges of the board along this trace line, right? But if you had another component like a resistor or a capacitor, well, the resistor, you could check the resistance, and then if you have a fancy, multimeter, you could also directly measure capacitance. Okay, so that does it for using the hot plate. Very simple, very easy, and once you have configured that file that sets the reflow profile, you can just keep running more and more boards, or do multiple simultaneously in parallel. For the next video, I'm going to show you how to hand solder the SMA connectors. So there we're going to be using a much higher temperature solder, the one that contains lead. And we're also going to be liberally using flux paste. Okay, so the flux is going to help us dissipate that heat, and that's going to come in particularly handy for these types of boards where, for example, here I have a ground plane and it's a solid connection to these ground pads, right? In other words, I'm not utilizing thermal vias, everything's solid. The trade-off is that it's harder to directly solder on components like this. You have to really heat up the entire board. But because we're interested in RF signals, it'll reduce the overall inductance and other parasitics, right? That would show up if these through vias, for example, were thermal vias connecting to those internal planes. Okay, see you in the next video.